Guide to CO2 heat pumps for sustainable heating solutions. CO2 heat pumps work by transferring heat rather than generating it. They extract heat from the ambient environment, which can be by air, water, or ground, and amplifies it for use in heating spaces. This procedure is attained through a refrigeration cycle. It starts with the evaporator, where CO2 evaporates at low pressure to absorb heat. The CO2 is then compressed, increasing in temperature and pressure. This is then passed through a heat exchanger, where it releases the absorbed heat to the space or water, which often involves a heat transfer medium such as a cylinder with coil or plate heat exchanger. After releasing the heat, the CO2 is expanded back to its low pressure state, ready to absorb more heat and continue the cycle. When it comes to choosing between CO2 and R290 heat pumps, it's essential to consider their respective advantages and limitations. In terms of environmental impact, CO2 has zero ozone depletion potential, ODP, and a global warming potential, GWP, of 1. On the other hand, R290 also has zero ODP but has a slightly higher GWP of 3. Additionally, CO2 heat pumps are highly efficient, especially in cold climates. Whereas R290 has excellent thermodynamic properties, leading to high efficiency and lower energy consumption. Lastly, CO2 systems can be more complex and costly to install due to the higher operating pressures required, whereas with R290 there are safety concerns with its flammability. When selecting a CO2 heat pump, numerous key features should be considered to ensure optimal performance and suitability for your specific heating needs. One of the most important factors is the heat pump's capacity. It is important to choose a heat pump with the appropriate capacity based on the area, number of outlets, and other factors. The installation requirements of the CO2 heat pump are also an important consideration. Some heat pumps may require specific installation conditions, such as adequate space for the outdoor unit, proper ventilation, and appropriate electrical connections. An additional factor is the assessment of storage water requirements to ensure there is available space. In conclusion, CO2 heat pumps are emerging as a solution for sustainable heating and hot water generation. With their high energy efficiency, low environmental impact, and high temperature capability, the low GWP of CO2 as a refrigerant also future-proofs CO2 heat pumps within future legislations. Also, these heat pumps provide consistent and reliable heating and DHW generation. As technology continues to advance, the performance and affordability of CO2 heat pumps are expected to improve further. Additionally, CO2 heat pumps represent a future heating and hot water solution for commercial projects. By embracing this technology, commercial heating and hot water projects can reduce their carbon footprint while providing acceptable performance and comfort. To receive the latest information on renewable technologies, legislation, and best practice, sign up to our free newsletter today through our website or by simply scanning the QR code.